Hello everyone, this is Ankit from Kailasha Foundation Fun and Learn portal. I hope you all are doing well. This is our third lecture of algebra and first lecture of calculus as well because we are discussing the chapter functions, which is common to both. Okay, so we will be learning all about functions. I will try to cover everything in this lecture. So let's start with relationships between variables. Relationships means there is a symbol like equal to, greater than, less than, greater than equal to, less than equal to, tends to, not equal to, etc. A relationship means this or approximately equal to. Okay. When we talk about relationship between variables, there must be one of these. But when we are talking about functions, it must be this only, equal to. Okay, so any connection between two variables for start. Okay, there are more than two variables also, but for start, for understanding, we'll start with two variables. Any connection between two variables involving a sign of equal to is can be a function. Okay, can be a function. I'm not telling you that it is necessarily a function. There are more restrictions, there are more conditions, there is a strict definition that we will be learning. Let me first give you a few examples like y is equal to 2x plus 3, y is equal to 4x square, y is equal to 1 by x given that x is not equal to 0. Okay, when there are no conditions given here, it is by default a real valued functions, a real valued function. That means that input and output both are real numbers only, no imaginary number, no matrices, no vectors, only numbers, rational numbers, irrational numbers, integers, fractions, decimals, prime, composite, natural, whole, everything but real numbers. Okay, so our entire syllabus will be focused on real valued functions, that input and output both will be real numbers only. That means all kinds of numbers that are not imaginary, all kinds of numbers that we know so far. Okay, so when for example like this, there is a condition written here that x is not equal to 0. Why? Because if x becomes 0, then 1 by 0 will be not defined. That I have told you in earlier lecture. One of the earlier lectures I have told you that 1 by 0 is not defined, it is not infinity, it is not defined. So, okay, so x is not equal to 0 is a condition here for this function. X is not equal to 0 is a condition here for this function. That means all other real number values are allowed in this function. Okay, so when there is no condition written, just like in these two examples, first and second, no condition is written here, that means x is a real number. That means input and output both are real. Okay, all real numbers are allowed. So these three are examples of functions. These three are proper ways to write a function. We can also write in place of y, we can write fx. What does fx means? F means function of x. Okay, x is the variable. Why x? Because this function is over x. This function is over x. X is an independent variable, and on that independent variable this function depends. If we put the value of this independent variable x, if we put the value of x to be 1, then it will be equal to 2 into 1 plus 3. Then f1 will become 2 into 1 plus 3, that is 5. Okay, sorry, 2 into 1 plus 3, that is 5. So f is a function of x. Okay, f of x, f of x. And as the three functions written here are three different functions, so we can't use the same symbol, so we use gx, hx, etc as per convenience. So this is how we understand functions. But now let me tell you a few rules. If some conditions are given or no condition is given, that means we know the input set. For example, in the first example, the input set is the entire set of real numbers. So if we put anything is in this function, we must get an output. Okay, the input must not remain without an output. There must be an output for every input. Okay, that is very necessary. And there must not be more than one output also. There must be exactly one output for every single input. For example, y is equal to x square. If y is a function of x, okay, if y depends upon x, then we can write fx is equal to x square. Fx is equal to x square, and if we put minus 1, we get minus 1 square, that is 1. If we put minus 2, we get minus 2 square, that is 4. We get one output, not two outputs. But if we think of the other side, that y is equal to x square and gy is a function over y, then what is x? X is equal to plus minus root y. X is equal to plus minus root y. That means if we put y is equal to 4, then we get x is equal to plus minus root 4, that is plus minus 2. We are getting two answers. We are getting two answers, and if we are getting more than one answer, it is not a function. So from this side it is a function, but from opposite side it is not a function. So y is a function of x. Y is a dependent variable, x is an independent variable, and fx is equal to x square. This is a function of x, but this is not a function of y. Gy is equal to plus minus root y is not a function of y, because it is plus minus, so we are getting two outputs every time. Okay, we must not get more than one output, and also we must not get less than one output. There must be one output only for every input. That is the rule for a given relation, given connection to be a function. Okay, if a given relation is a function, then there must be exactly one output for every input. Okay, so now we'll be moving to the chapter. Let me tell you, a function can be visualized as an input output machine. Function can be visualized as an input output machine. This is a machine, this is an input. We put the input inside the machine and we get the output as fx. Okay, for example, x square, it is a machine. We put 2 inside it and we get 4. Okay, we put 2 inside it, we get 4. If we put anything, we are getting an answer every time. We know that every time we'll get an answer. We will never be disappointed. We will get exactly one answer every time. We won't get two answers also. But if we construct a machine like this, plus minus root x, then if we put 16, we get plus minus 4. Okay, we are getting two answers, plus 4 and minus 4. So this is not a function. Okay, this is not a function. So function is an input output machine which gives one output for every input. Okay, so is this a function? No. Is this a function? Yes. There's a difference. If we simply write hx is equal to 1 by x, that means we haven't mentioned any restriction. That means every real number is allowed. 0 is a real number. When we put 1 by 0, we don't get an output because it is not defined. So it is not a function because it is an input output machine which is not giving an output at x is equal to 0. If it is not giving an output at any single point, then it is not a function. But if we write, if we mention that it is a function which we have defined for x is not equal to 0, so we are not allowed to put x equal to 0 in this function. All other values are allowed, and if we put any other value, we are getting an answer. For example, 1 by minus 15, we are getting an answer. If we put 1 by 2000, we are still getting an answer. Okay, so we are getting an answer for every input, so it is a function. Okay, and for any output, we are not getting more than one output also. For any input, we are not getting more than one output also. So uh, it is definitely a function. Now let us learn a few terms related to function. Let us learn a few terms related to function. Domain, the allowed set of input. Range, the actual set of output. Codomain, sometimes larger than range, the desired set or allowed set of output. No element of range, no element of range can fall outside codomain. Outside codomain. That means if a value belongs to the range of a function, it must belong to the codomain also. Codomain is most of the times equal to, codomain is same as range most of the times. Otherwise, it is bigger than range and it contains the entire range. Okay. For example, y is equal to x square. We know, you know, all of us know that every output we'll get will be a positive number. Y is equal to x square. When we square any real number, we'll get a positive number every time, or maybe 0. Okay, so our range is 0 to infinity, all real numbers. Okay, 0 to infinity, all real numbers, that will be our range. But we can say codomain is all real numbers. We allow negatives also, though we are not getting those. Though we are not getting the negatives, but we allow that this is our entire codomain. If in a particular question, if the given function is not a famous function, is not a very common function, then if codomain is not mentioned, then it is by default all set of real number. For example, modulus function, we are always getting positive numbers as output, and if codomain is not written, then we can take codomain to be the set of all real numbers also. Okay, suitably. So obviously all real numbers will not be there in the range because negatives are not allowed. So no problem, we are taking a bigger set. We can't take a smaller set, we are taking a bigger set, and that set, the set of all real numbers, already contains the positive numbers. Okay, so no part of range can be outside the codomain. Sometimes larger than the range, the desired set or allowed set of output is codomain. No element of range can fall outside codomain. That means codomain contains the entire range. For example, it is codomain, so range will be this. Range will never be outside this like this. Okay, range will always be inside this or equal to this. So domain, codomain, and range. Now we'll see a few examples to understand this chapter better. Let us take a look at example 1. A is equal to 1, 2, 3, 4, and B is equal to A, B, C, D, E. Let function f from set A to set B. Yes, we read it like that only. F is a function from set A to set B. Okay, it is an illustration. So we present these like this: 1, 2, 3, 4, A, B, C, D, E. This is A, this is B, this is domain, this is codomain. Because this is the allowed set, this is the allowed set, this is input set, this is output set. So domain and codomain. Now the function is defined like, let me show you. One for 1 we are getting C. When input is 1 we are getting C. We are defining it. In the example the function is defined like this. For 2 we are getting E. For 3 we are getting B. For 4 we are getting C again. So now domain is this entire set. Domain can never be other than this. The first set is the complete first set is the domain. Okay, now codomain is A, B, C, D, E, but range is the actual output set. So range is the actual out. A is not in the output, D is not in the actual output set is B, C, E. So this is the range. Okay, B, C, E. Now can we say that given function is a valid function? Yes. Why? Because all inputs are getting an output, and no any input is getting more than one output. A few students are confused and they say that, sir, see here, for C we have two inputs, 1 and 4, but for C we have two inputs. For C we don't have two outputs. I'm talking about not more than one output. So we don't have to worry about this set. We don't have to worry about this set. It can be anything. It maybe only one element is connected to the input set. That doesn't matter. Only the only thing that matters is every element in the input set is connected to something. Okay, so 1 is connected to something, yes. 2 is connected to something, yes. 3 is connected, yes. 4 is connected, yes. Is any of these connected to more than one? No. One has only one answer, unique answer, C. When we ask 2 we get E. When we ask 3 we get B. We don't get two answers. When we ask 4 we get C. Okay, so for every question we have an answer and we have a unique answer, so it is a function. That's what I was telling. Now let us consider a few more cases. Sorry. Uh, A, 1, 2, 3, 4, A, B. Is it a function? No, because this input is not getting an output, so it is not a function. Okay, not a function. Now x, y, w, z, 1, 2, 3, 4, 5, 6, x to 3, y to 1, y to 2. Okay, then z, w to 2, w to 4, z to 6. Is it a function? No, because y, for the input y we are getting two different answers, and for the input w also we are getting two different answers, but we can't get two different answers for any input if it is a function, so it is also not a function. Not a function. Okay, now types of functions. It is a one to one function. One to one function. Okay, it is a many to one function. Slight change and it becomes many to one, because two inputs are giving same output. Sir, but this one is giving only one. That doesn't matter. The one to one criteria has failed. So it is many to one. Okay. One to one, many to one. It is also many to one. It is also many to one. Because at least two inputs are there for which we are getting the same output. At least two inputs are there for which we are getting the same output. So the one to one condition is violated and it is a many to one. If a function is not one to one, then it is many to one. Okay. There are only two kind of functions, one to one and many to one. So what about one to many? Can we get one to many? No, not at all. Why, sir? Because if it is one to many, if it is one to many, then it would not be a function at all. If it is one to many, then it would not be a function at all. You are getting my point? Because for this input, we are getting two outputs. That is not possible for a function. So a function can't be one to many or many to many. A function can only be one to one and many to one. So this one was one to one. Now let me show you a few examples of many to one. This is many to one. Sorry. Classic example of many to one. But others are also many to one. Like this. Okay. This is many to one. These both of these are many to one. So one-to-one function is called injective function, and many-to-one is called not injective. A function not injective is many-to-one. Okay. Now we'll consider onto and into functions. Onto functions. You see a few functions in which one, two, three, four, a few elements are there in the codomain, but a few of them are left. Okay. A few of them are left. These two are left. If these two are left, or any of the elements is left, that means codomain is not equal to range. If codomain is not equal to range, then it is not onto. Not onto. If not onto, that means into. Okay. If codomain is equal to range, if codomain is equal to range, that means codomain equal to range. That means the entire codomain is mapped. No element is left here like this. No element is left here like this. That means codomain is equal to range, and the function will be, then the function will be onto. Then the function will be onto. And it is called surjective function. Surjective function. So a function which is not onto is into, and it is called not surjective. Okay. Now a function both one to one and onto, that means injective and surjective, is a bijective function. Bijective function. If a function is bijective, if a function is bijective, then it is invertible, invertible, and vice versa. Okay, a many to one function can never be invertible, because when you try to invert this function, you are getting one output for two inputs. But now if you invert this, if you turn it sideways, then it becomes like this. Then for one input you are getting two outputs, that would violate the definition of the function. So it is not a function now. That means this function cannot be inverted. So a many to one function cannot be inverted. Also, if a function is not onto, that means it is into, that means a few elements in the codomain are left. If left, then if we invert this, then this will come on this side, and on this side this element will be left. But that is not possible. All elements of the domain must be mapped. All elements of domain must be mapped. That is necessary. So this function is also not invertible. So for a function to be invertible, it must be bijective. That means both injective and surjective. That means both one to one and onto. A one to one and onto function looks usually like this. No element left and no double mapping. Okay. Now we'll be discussing a few good examples. A function a function fx is defined as fx is equal to x square plus x for all x belongs to R, that means real number x. If it was not written, then also we would consider that only. I told you already in this lecture a few minutes ago that if no condition is written, that means we can take all real numbers. So for what values of x? Now, for what values, sorry, of x is fx equal to 0? For what values of x is fx equal to 0? Solution: fx is equal to 0. That means x square plus x is equal to 0. We can take x as common, x plus 1 is equal to 0. Now x is equal to 0 or x plus 1 equal to 0. What is the condition? X must be a real number, that only. X equal to 0 or x is equal to, sorry, minus 1. So both are real numbers, so we get two answers, x is equal to 0 or minus 1. Next example, uh, a function fx is defined as fx is equal to x square plus 2 for all x belongs to z. That means integer set. X belongs to z. Z is the set of all integers. That is a standard notion. Okay, that will be discussing again in the chapter set theory. And also condition is given x. That means we can do rough work that x is equal to, sorry, x belongs to this set 0, 1, 2, 3, 4, 5. Okay, this only. A function fx is defined as fx equal to x square plus 2 for all this. And now the question is, what is the domain of, what is the domain of f? B. What is the range of f? We can write fx as y. We can, I just told you what can be put in place of x. So 0, 1, 2, 3, 4 and 5. So for x we have x square plus 2. So for 0 we'll have 0 square plus 2, that is 2. 1 square plus 2, that is 3. 2 square plus 2, that is 6. 3 square plus 2, that is 11. Okay. 4 square plus 2, that is 18. Oh my. Okay. Sorry. 5 square plus 2, that is 27. Extremely sorry for this. 27. Okay. So domain is this 0, 1, 2, 3, 4, 5 and range is this. Okay. Domain is this and range is this. Now, mm, let us take a look at two variable function. Question: if f a b is equal to a plus b plus a square b cube minus a cube b square. Okay, find f12. Fab is equal to this and this. So in place of a we put 1 and in place of b we put 2. So f12 will be equal to 1 plus 2 plus 1 square 2 cube minus 1 cube 2 square. That is 1 plus 2, that is 3 plus this is 8 minus 4. 11 minus 4, that is 7. Okay. Now question is, can you express fx in terms of x from the following? 2fx minus f1 by x is equal to x square. Okay. 2fx minus f1 by x is equal to x square. Solution. If we put 1 by x in place of x in the entire equation, then we get 2f1 by x minus f1 by 1 by x, that is x is equal to 1 by x square. Okay. And if this was equation 1 and this was equation 2, we multiply the equation 1 by 2, we get 4fx minus 2f 1 by x is equal to 2x square. Now we add these two, this will be cancelled out. It will be 3fx is equal to 3fx is equal to 2x square plus 1 by x square. Now fx will be equal to 2 by 3x square plus 1 by 3x square. Okay. So yes, we can express fx in terms of x. This is our final answer. Okay. We have to write a few things, but that is pre-assumed. If in question it is not written that x is not equal to 0, we have a common sense that it must be there, x is not equal to 0, because f1 by x would be meaningless in case that is not given. So we take that readily assumed that x is not equal to 0. Here also it is 1 by 3x square, so x must not be equal to 0. That is a readily assumed condition. Okay. Now we'll be concluding this lecture for now, so that this lecture is not so lengthy that you might get bored with the lecture. So I will try to cover remaining topics in the subsequent lecture. In that lecture we will be discussing even and odd functions, iterative functions, composite functions, periodicity of functions, okay, modulus, and a few types of functions, modulus functions, and then graphs. I already told you in earlier lecture of algebra, previous lecture. We will study greatest integer function, log, exponents. Okay. and then I'll be discussing the log chapter also. The logarithms chapter has a very good weightage in cat. So if you have any feedback, if you didn't like the lecture, if you are confused at any point in the lecture, then you can report to me on, sorry, 8294600 829. Okay, so thanks for watching this video. Don't forget to like, share, subscribe. Thank you so much. Happy learning. Bye bye. Good night.